All right, let's talk about the invisible guardians of your digital life. Today, we're diving into two super important security protocols, TLS and DTLS. You've probably never seen them, but they're the reason you can browse, shop, and call people online privately. And as you're about to see, they go about it in two very, very different ways. Think about your average day online. You're sending emails, you're on a video call, you're checking your bank balance. And in all those simple actions, you're actually running into one of the biggest challenges on the internet, this constant tug of war between being super reliable and being super fast. You've definitely experienced this, right? You log into your bank's website and every single piece of data is there, perfectly loaded, no exceptions. But then you jump on a video call and all of a sudden the audio cuts out for a second or the picture freezes. What gives? Well, the answer to that is all about how the internet decides to send your information. So that difference we were just talking about, it all comes down to the fact that the internet basically has two main ways of getting data from point A to point B. You can think of them as two completely different types of messengers, and everything else we do online is built right on top of them. Now, these two messengers are called TCP and UDP. First up, you've got TCP, the Transmission Control Protocol. This one is like a super reliable armored courier. It makes a formal connection, it guarantees every single packet of data arrives, and it checks to make sure everything is correct. It's slow and steady. On the flip side, you've got UDP, the User Datagram Protocol. This is your speedy live stream. It just blasts out little packets of data called datagrams in a fast one-way trip. It doesn't check if they arrive, it doesn't care about the order, it's all about low latency, pure speed. But here's the catch. For all their differences, they share one massive critical flaw. By default, both TCP and UDP are basically shouting your data across the internet. Nothing is encrypted. They're just operating out in the open, which leaves them totally vulnerable to anyone who wants to listen in or even mess with the information being sent. And that's exactly where our security protocols have to step in. So let's start with our reliable courier, TCP. When you absolutely need to add a layer of armor to that guaranteed delivery system, you bring in the big guns, Transport Layer Security, or TLS for short. TLS is the gold standard for securing internet connections today. Now, you might have heard of its older sibling, SSL, that's Secure Sockets Layer, but TLS is the modern, much more secure version we all rely on. Its whole job is to provide the three pillars of online security, making sure you're talking to who you think you're talking to, encrypting the conversation, and making sure the data isn't tampered with. So, how does it work its magic? Well, it all happens through a little dance called the TLS handshake. It's basically a multi-step negotiation. First, your computer and the server say hello and agree on the rules. Then, the server shows its ID, its certificate, to prove it's legit. After that, they work together to create a secret key that only the two of them will know. And finally, they send an encrypted finished message to confirm that the secure tunnel is officially open. All this back and forth is what makes it so incredibly secure. But, each of those round trips adds a little bit of time, a little bit of latency. Okay, but what about our speedy live stream, UDP? You can't slow it down with a meticulous handshake that demands every packet arrive in perfect order. That would defeat the whole purpose. For that, you need a totally different kind of security. And that brings us to DTLS. Meet DTLS. That stands for Datagram Transport Layer Security, and the name pretty much says it all. It's basically a cousin of TLS, but it's specifically built for those fast, disconnected datagrams that UDP sends. The goal is the same, provide top-notch security, but to do it for apps where every single millisecond matters. And here's the really clever part. The core strength of DTLS is that it's designed from the ground up to expect chaos. It knows that packets are going to get lost, it knows they might show up in the wrong order, because hey, that's just how UDP rolls. So instead of breaking down, it provides a layer of security that can handle all that unreliability without causing the kinds of massive delays that TLS would. All right, so now that we've met our two security protocols, we've got the armored truck and we've got the on-the-fly encryption for the race car. So let's put them side by side and really dig into what makes them different. This table really lays it all out. TLS, our armored truck, runs on reliable TCP. DTLS runs on speedy UDP. TLS guarantees every packet shows up in the right order. DTLS just lets them fly because speed is what counts. When a TLS session is over, it sends a formal verified goodbye message. DTLS, it just stops sending data. Poof, it's over. And get this, for spoofing protection, TLS relies on that multi-step handshake, but DTLS uses this really clever trick called a cookie exchange.
It basically makes a client prove it can actually receive data at its IP address before the server wastes any time or resources on it. It's a lightweight way to get the job done.
So where do you actually run into these protocols in your day-to-day life? The answer is literally everywhere. They're not competing with each other. They're working together to secure the entire web, with each one playing to its own unique strengths. You are using TLS constantly. See that little lock icon in your browser's address bar? That's HTTPS, and it's powered by TLS. It's also what encrypts your emails, what secures single sign-on services when you log into different apps, and what protects you in any situation where losing even a single byte of data is a total disaster, like a file transfer or signing a legal document. And DTLS? Well, you're using that in all the places where speed is everything. A lot of popular VPNs use it to give you a secure connection that doesn't feel sluggish. It's the secret sauce behind real-time communication apps like Google Meet or Zoom that use WebRTC. It's what keeps your online gaming responsive and your live streams from buffering. It's all about real-time performance. So at the end of the day, it's not a question of which one is better. TLS and DTLS are not competitors. They're just specialized tools in the same toolbox. One's a hammer, the other is a screwdriver. You absolutely need both of them to build the modern, functional, and secure internet we all use. One gives us certainty, the other gives us speed. And together, they keep our digital world safe. And that really leaves us with a final big question to think about. As our world demands faster games, clearer video calls, and more instantaneous data, that tension between speed and security is only going to get more intense. The evolution from SSL to TLS and the creation of DTLS shows how we've handled it so far. But the challenge for the future is still wide open. How will we keep innovating to get the incredible speed we all want while maintaining the absolute security that we all need? It's something we'll all have to figure out together.